Hello, welcome to Space-Based Solar Power course by Dr. Ayonshola Ogundele of A4S Aerospace, a product of Astronautics for Exploit. Space-Based Solar Power course preview is given as follows: insights you will gain, skills you will gain, target audience, and course description. Insights you will gain are as follows: evolution of space-based solar power, timeline of solar energy, advantages and disadvantages of space-based solar power, 28th century space-based solar power early concepts, and 21st century space-based solar power concepts. Applications of space-based solar power: spacecraft powering, space stations powering, global power supply, lunar and Martian bases powering, interplanetary exploration missions powering, in-space manufacturing, sustainable energy, supplement for existing power infrastructure, and solar cells. Space-based solar power ecosystem: launch segment, ground segment, space segment, and investment, regulation, and research and development institutions. Current trends of space-based solar power system: space-based solar power technological advancements, and space-based solar power in space assembly and maintenance. Other insights are space-based solar power pilot projects and test cases, such as solar power demonstrator, solar power incremental demonstrations, and research, energy orbit concept as a way to provide power to multiple satellites in low Earth orbit using a network of small space solar power satellites and solar arrays. The skills you will gain are as follows: critical thinking about space-based solar power, confidence to speak boldly about space-based solar power, ability to be able to interpret, evaluate, and understand space-based solar power, and development of space-based solar power innovations. The target audience is as follows: students, industries, academics, researchers, government, and space enthusiasts. The course description is as follows: space-based solar power: the concept of collecting solar power in outer space using solar power satellite and transmitting it to the Earth, once thought to be a futuristic idea, is gradually becoming a reality. Over many decades, researchers have been working on how to put solar panels in space, harvest sunlight, and beam the harvested sunlight into the Earth for human consumption. Due to the closeness to the Sun compared with the Earth, solar panels in space produce higher power. Via science fiction stories, novels, feasibility studies, and proposals, several illustrations of the transmission of solar power through space-based systems have been demonstrated. In 1941, the idea of space-based solar power was described by science fiction writer Asimov in a short story, and since then it has been evolving. Presently, based on its enormous benefits, there is an ongoing global race for space-based solar power and exploration of the idea by several countries such as the United States, China, European Union, Russia, Japan, India, and a host of others. Space-based solar power is catalyzing various space exploration missions. This is made possible by several nexus of emerging technologies such as artificial intelligence, machine learning, robotics, digital twins, and a host of others. The concept of space-based solar power projects involves the launching of large solar power satellites made up of smaller modules to high orbit closer to the Sun. One of the propositions of the accomplishment of space-based solar power was to assemble smaller modules in space via autonomous robots. The space-based solar power course is aimed at disseminating the concept of space-based solar power. Current trends such as in-space assembly and maintenance strategies using robotics, research and development of space-based solar power transmission techniques, and various space-based solar power pilot projects and test cases. In this course, You will learn about evolution of space-based solar power, applications of space-based solar power ecosystem, current trends of space-based solar power system, and space-based solar power pilot projects and test cases. Thank you for your attention.